Welcome to my friends. Today's lectures we have discussed the topic carbonyl compounds. Now in this topic we are going to learn the reagents of sodium borohydride. So various reactions with sodium borohydride. The previous lectures we have seen the reagents lithium aluminum hydrides. They are used for reduction of aldehyde and ketone. Similarly, these sodium borohydrides also reduce the aldehyde and ketones, but it selectively reduces only aldehydes. It does not reduce some of the other functional group, and therefore it is less reactive and mild hydride reducing agents. Reduction may be carried out in alcohol or in aqueous solution. They provide alkaline. But reduction is carried out by refluxing aldehyde or ketone with sodium borohydride in methanol or the ethanol as a solvent. In the first step, similarly to lithium aluminum hydride, the 4 molecules of this aldehyde or ketone, they will reduce 1 molecules of the sodium borohydride simultaneously. Similarly, ketone also reduce the 4 molecules of the ketone reduced by 1 molecules of the sodium borohydride simultaneously. In the second step, what happens? The complex will form, and those complex, which complex? Like these complex, they will hydrolyze with the dilute acid. They get into 4 molecules of the alcohol will produce as the final products. Therefore, the 1 molecules of sodium borohydride get reduced 4 molecules of aldehyde or ketones. Similarly, lithium aluminum hydride. Sodium borohydride also reduces aldehyde into primary alcohol and ketone into secondary alcohol. Now these reactions we have seen here. So those aldehyde can reduce sodium borohydride to corresponding alcohol, that is the primary alcohol. And ketone, so these ketones can convert to CHOH, CH2OH. 1 hydrogen add to this carbon and 1 hydrogen add to oxygen. Right? The product is very simple. 1 hydrogen is here and 1 hydrogen is here. So CHOH, so secondary alcohol is the final product. So this aldehyde can treat with sodium borohydride in methanol as a solvent, and after forming the complex with hydrolysis with water and to get the primary alcohol, in place of aldehyde use the ketones to get the secondary alcohol as the product. But the sodium borohydrides, which are very less reactive as compared to lithium aluminum hydride, and therefore it selectively reduces only with polar aldehyde and the ketone group. But it does not reduce nitro group, cyano group, and also carbon-carbon double bond. That is a non-polar functional group, alkyne, arene. So those number of groups cannot reduce sodium borohydride. It is selectively reduced only and only the aldehyde and ketonic group. From those examples which are clearly shown is here, this is a unsaturated aldehyde can treat with sodium borohydride in methanol. They will reduce only aldehyde group to corresponding alcohols. It does not reduce carbon-carbon double bond. These carbon-carbon double bonds which are unaffected or undisturbed. So sodium borohydride is selectively reduced only and only aldehyde group to alcohols. Similarly, This benzaldehyde can treat with sodium borohydride in methanol. They reduce this aldehyde to corresponding alcohol. So CH2OH. Similarly, this nitro group which is not reduced by sodium borohydride, one missing is there, like sodium borohydride. So one missing. Sodium borohydride, on heating conditions, they will reduce only aldehyde group to CH2OH. Similarly, it is also only reduce aldehyde group. It does not reduce benzene ring. It is also only reduce aldehyde group corresponding CH2OH, CH2OH, CH2OH. It is a product by sodium borohydride. Next point, we are going to discuss the mechanism of reactions. So various mechanism we are discussing here. The first mechanism, benzoin condensation reaction. Benzoin condensation reaction, it means that the condensation can take place self condensation. It means the two molecules having the similarly of aromatic aldehyde with very important no alpha hydrogen will be there, right? Benzoin condensation, it is a self condensation of aromatic aldehyde with the no alpha hydrogen atom in presence of the cyanides like a potassium cyanide ions as a catalyst, and 2 gives aromatic alpha hydroxy ketone. This is called as a benzoin condensation reaction. For examples, the benzaldehyde can treat with potassium cyanide in alcohol solvents to get the product as aromatic alpha hydroxy ketones. This is alpha carbon, so alpha hydroxy, this is a ketone. Now we have see the mechanism. This is very important part. So how will you affect this? 1 minute. Like this, in color we have C is here. So which color? Yellow color we have key one is here like this. So 1 minute. Another color we have given as like anyone colors. So those color we have key, right? So this attack of nucleophiles cyanide ion, you know that cyanide CN minus is attacked on this carbonyl carbon and to form negative charge on oxygen. Cyanide is a good nucleophile and therefore is attacked on this carbonyl carbon and form negative charge on oxygen areas, right? And then after formation of this oxyanion, our name is a oxyanion, those oxyanions by rapid proton can transfer areas can take place. Rapid proton transfer, it means this O minus proton can pick up this proton. So this O minus can pick up the protons and they will convert to OH by forming negative charges here. So these carbanion negative charge and those carbanion which are stabilized. Why it is stabilized? Because it is electron donating resonance effect. So this minus charge is going to forming keys to stabilize on nitrogen. Similarly, those negative charge on this side which is stabilized by the benzene ring. So these carbanion formations which are more stable, right? In the second step, what happens? Then these another molecules of the aldehyde can add, that is a nucleophilic addition to the carbanion or nucleophilic addition of carbanion to the aldehyde. So this carbanion formation can add to another molecules of aldehyde. So these negative charge attack on this carbonyl carbon and to form negative charge on oxygens are here like this, right? This is a negative charge on oxygens, and in this formation of those molecules or the intermediate, rapid proton change can transfer or rapid proton transfer can take place. So which protons can take place? So this O minus can pick up the proton from, and is O minus convert to OH is here, and this is a negative charge. Okay. So this is the formation of this intermediate. Then after third step, what happens? Elimination of cyanide. Third step, elimination of cyanide. So how will you eliminate these cyanides? Those molecules can take is here. So this negative charge on oxygen is reversed to form carbon oxygen double bond is here and replace Cn minus, right? Replace Cn minus and to form this alpha hydroxy. This is a alpha carbon. This is alpha carbon. So alpha hydroxy ketone. This is called as the benzoin condensation reaction. Now next points we are going to discuss applications of benzoin condensation. It is very simple. Two molecules of these. It is a para anisaldehyde. This is a anisaldehyde. The two molecules of anisaldehyde get condensed with cyanide heating. So how will you get the products? Products are very simple. One molecules of this, other side those molecules similarly, and to these molecules can attach with one carbon having the carbonyl group and one carbon having the OH group. So write these products very simple for the application of this benzoin condensation. Similarly, other products. So two products can write from left is one and right is one. This is a left, right? This is a right is one. So two molecules similarly write left and right is here, and these two molecules joined one of this carbonyl group and one of this OH group, right? So we can write the products is very simple. Next type of condensation, now we are going to discuss the Novingial condensation. Next type condensation, now we are going to discuss the Novingial condensation reaction. This type of condensation reaction also the condensation of aldehyde and ketones having no alpha hydrogen atoms. It is also the condensation reaction may take place having a no alpha hydrogen atoms with one of these active methylene compounds in presence of the basic catalysts are called as Novingial condensation reaction. So this is one of the aldehyde or ketones. This is one of these aldehyde or ketones having the no alpha hydrogen atom, right? No alpha hydrogen atoms condensed with active methylene compound. This is a active methylene compound, that is R3 and R2. They will be electron withdrawing group in presence of the basic catalyst and to form this alkene. This is called as a Novingial condensation. But in Novingial condensation, the catalyst mostly used as the mono ditrialkyl amines, anilines, pyridine, alkoxide, etc. But in R2 and R3 groups, which are very important for the activate those carbons, like the electron withdrawing group like aldehyde, the ketone, ester, nitro group, sulfur group, sulfonyl group, sulfonate group, and R, this R, they will be hydrogen alkyl group or the aryl group. The ketones are less reactive than aldehyde due to in ketone both larger group which is present on both sides and therefore which are less reactive than the ketone. Now we have seen these examples are here. Is one of the aldehyde having the no alpha hydrogen is there and it is a active methylene group. So these two molecules can condense with each other. The one of the base pair uses diethyl aniline, but the product is the unsaturated product like alkene, right? So mechanism, now these parts which are very important to we have seen. It is a base catalyzed aldol type of condensation reaction. In first step, the formation of carbanion. First step, the formation of carbanion. It is one of the base. By take the proton from this, two proton is there. So one of the proton is picked up by this base and two form negative charge is here. So this is negative charge is stabilized by both electron withdrawing group are here. This carbanion is stabilized by both electron withdrawing group and hence formation of carbanion. So this carbanion is formation can take place in the first step. In the second step, what happens? The second step is a nucleophilic attack of the carbanion. So nucleophilic, this is carbanion attack on this carbonyl carbon having electron deficient carbons to form the oxyanion, right? So negative charge on this carbon attack on this carbonyl carbon and to form negative charge on oxygens, right? This is oxyanion will be there in the second step. And in the third step, what happens? Protonation of oxyanion to form aldol, and they undergo dehydration to form alpha beta unsaturated compounds, right? So this is oxyanion can pick up the proton from the base. So this O minus convert to OH, right? This O minus convert to OH, and then after this hydrogen and this OH removal of water molecules. So this pick up the base by take the protons, form double bond is here and replace the water molecules, right? And to form alpha beta unsaturated carbonyl, it is from the unsaturated molecules, alpha beta unsaturated compounds. Now we have seen the applications of Norwegian reactions, right? Applications of Norwegian reaction. The first applications we see is here the preparation of unsaturated ketones. So it is very important. The one of the aldehyde we are taken is here having no alpha hydrogen atoms, right? And this is a active methylene compounds. Put this both molecules condense with each other by taking the, it is a good base to form negative charge on this carbon to form carbanion is attack on this carbonyl carbon, right? So product, how will you write, is very important for Norwegian reactions. Norwegian reaction, this is one of the oxygens and this is the two protons can replace, and to join is here is very simple, to carbon carbon double bond, right? And then after formation of double bond by Norwegian condensation reaction by taking dilute KOH. So dilute KOH are used for this ester hydrolysis. Ester convert to acid, right? This ester is convert to acid, and then after heating the loss of this CO2, right? Loss of this CO2 and convert benzylidene acetone having the carbon carbon double bonds. The preparation of unsaturated ketone can be take place by Norwegian condensation reaction. Next applications we have sees here preparation of alpha beta unsaturated acid. Similar reaction can be done like the condensation, Norwegian condensation reactions by loss of water molecules to get carbon-carbon double bond is here. Then after formation of unsaturated carbonyl compounds to take dilute KOH HCl, that is hydrolysis with water, the both ester group, this is one, this is a second ester group, may be hydrolysis into this acid, and then by heating conditions loss of one of the CO2 are here. So this loss of one of the CO2, and therefore one of the CO2 is remaining, sorry, one of the COH will be remaining, one of COH will be cancelled. So from alpha beta, this is a alpha carbons and this is a beta carbons, right? So this is alpha and beta carbons to form alpha beta unsaturated the acids. Next examples or next applications, preparation of unsaturated dicarboxylic acid. In place of ethyl acetoacetate, we are use malonic esters, right? Last times we have used the ethyl acetoacetate is use malonic ester. It means 2-OAT group, that is ethoxy group. It is also one of the ethers. So both ethoxy group is there, and reactant can take place as a glycolic acids. Glycolic acids. This ethylamine, sorry, pyridine, it is a weak base. So this base can pick up the protons from this carbon, and this carbanion attack on this aldehyde and to replace the water molecules and to form unsaturated molecules as like this, right? And then after formation of this unsaturated intermediate can treat with dilute acid, then what happens? Similarly, the both ester group can hydrolyze to acid, right? This is one of the acid and this is a second acid. Means both ester can convert to corresponding acid, and then after heating one of these acid will be lost, right? One of the acid will be lost, that is to form fumaric acid, right? One of this acid, one carboxylic acid will be removed and to form one of the acid are named as fumaric acid. You know that fumaric acid are trans, right? Trans. Why it is a trans? Because similar group which are opposite side. This is a similar group is on opposite side. Therefore, it is a trans acid. Name is of fumaric acid. Right? Thank you.